Hello everyone, welcome to another session on application of Bernoulli's principle. Next application is orifice meter. Like venturi meter, orifice meter is also a device which is used for measuring the rate of flow. It consists of a flat circular disc with an orifice which is placed concentric with the pipe. This is my pipe in which I have placed a circular plate which has a hole in it. This hole is called as an orifice. This section 1 is the diameter of the pipe and the section 2 is marked very close to the orifice plate. Now this is the direction of flow. Because of this plate which is attached over here, there is a sudden decrease and then an increase of the area. The section 1 and section 2 are connected to a manometer. We can see a clear difference of mercury in the two sections. This is a U-tube differential manometer. The diameter at this orifice is approximately 0.5 times the diameter of the pipe which is at section 1. The discharge to the orifice meter is given by the formula Q is equal to CD A1 A2 root of 2GH upon root of A1 square minus A2 square, where D1 is the diameter of the pipe and hence we can calculate area A1 which is pi by 4 D1 square. D2 is the diameter of this orifice and A2 will be calculated as pi by 4 D2 square. CD is the coefficient of discharge. The value of CD for orifice meter is 0.55 to 0.65. This is the range for CD. For venturi meter, this value was 0.97 to 0.99. Hence, we can say that the efficiency of venturi meter is more than orifice meter. And also it is seen that venturi meter is widely used as compared to orifice meter. Now let's take up some numericals on orifice meter. The first one, an orifice meter with orifice diameter 10 cm is inserted in a pipe of 20 cm diameter. The pressure gauges fitted upstream and downstream of the orifice meter gives readings of 19.62 Newton per centimeter square and 9.81 Newton per centimeter square respectively. So what is given is diameter of the pipe D1 which is 20 centimeter. I have converted into meter 0.2 meter and the area is calculated as pi by 4 D1 square. Diameter of orifice D2 is given as 10 centimeter which is 0.1 meter and the area A2 is pi by 4 D2 square. If you read carefully, the pressure upstream and downstream is given. Upstream means at section 1, downstream means at the section 2. So at section 1 P1 is 19.62 Newton per centimeter square. I have converted into Newton per meter square, and pressure P2 is 9.81 Newton per centimeter square, which again I have converted into Newton per meter square. Coefficient of discharge for the orifice meter is given as 0.6. CD value is 0.6. Find the discharge of water through the pipe. We have to find the value of Q. Now Q has a formula CD A1 A2 root of 2GH upon root of A1 square minus A2 square. Now since P1 and P2 is given, I can use the formula of H equal to P1 upon rho G minus P2 upon rho G. P1 and P2 is known. Since the flowing fluid is water, hence rho will be 1000 and G is 9.81. If you substitute all the values, you will get the value as 10 meters of water column. If the value of H and all other data is substituted in this formula, then we get the answer of Q as 0.06817 meter cube per second, which is 68.17 liters per second. Let's take up another example. An orifice meter with orifice diameter 15 cm is inserted in a pipe of 30 cm diameter. So the diameter of the pipe D1 is 30 cm, which is 0.3 meter, and the area can be calculated. The orifice diameter D2 is given as 15 cm, which is 0.15 meter. So the area can again be calculated as pi by 4 D2 square. The pressure difference measured by the mercury oil differential manometer on the two sides of the orifice meter gives a reading of 50 cm of mercury. So the manometer reading X value is given as 50 cm of mercury, which is 0.5 meter of Hg. Find the rate of flow of oil of specific gravity 0.9 when the coefficient of discharge of the orifice meter is 0.64. CD is given as 0.64. Specific gravity of oil S0 is given as 0.9. We have to find the value of Q. Again using the same formula of Q, and for H the formula this time will be H is equal to X into SH upon SO minus 1, where SH is the heavy fluid specific gravity and SO is the specific gravity of the flowing fluid. Here it is oil. When I substitute all the values, I get H is equal to 7.055 meter of oil, and when the value of H and other data is fed into this equation of Q, you will get the answer of Q as 0.1374 meter cube per second, which is 137.41 liters per second. Thank you.